All right, welcome back to Mr. P. Helps with Geometry. This is Unit 1, Topic 2, Lesson number 5. So this time we're going to be reflecting, but we're going to be writing rules for reflections. And starting off with a warm-up here, this is a translation, slides, 8 left, 5 down. So all you have to do is move each point 8 left and 5 down, and then you'll end up with the exact same triangle. Now, I didn't actually count it out, save yourself a little bit of time for this video. And this one over here is going to be right 8 up 10. So you just simply move each point right 8 up 10. And then wherever it ends up, you end up with the exact same rectangle. It would be somewhere in this. Okay, obviously it would be more like this. But it'll be somewhere in that vicinity. Now, I really want to focus on this lesson in particular, talking about reflections and how to write that rule. Now, in this activity here, it says reflect point B over the x-axis, and we have done that in the last video. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, that means that point B, which was at 2, 6, is now at 2, -6. And then what you notice is that the x stayed the same and the y changed to the opposite. And that is what's going to happen for all of the points. If I do the same thing for f, which is at 11, 3, and then I reflect it, it's going to end up at 11, -3, because it's just moving straight down. So its x is not affected in this case. So if I have this point, then I know it's going to end up at 482 and then -167 because the y is going to change to the opposite. So xy turns into x opposite y. So whatever the y is, it just changes to the opposite. If it was positive, it turns negative. If it was negative, then it turns positive. And it is simple as that. So in this question, so if I pick a point, doesn't really matter where. So this happens to be at 3, 3. And then I use this rule on it, so the x stays right where it's at, but the y changes to the opposite, which is -3, and then you're going to see that that is a perfect reflection over the x-axis. Now, this one is something that we haven't seen before, so if I pick that same point, actually I'm going to pick a different point, so let's say we use 1, 3, which is right here, and I use this rule, which means it's going to flip from xy to yx, meaning 3 and 1 just simply switch. So that becomes 3, 1, which is right here. So this is actually the rule for reflecting over y equals x. So that's what this is, reflecting over this diagonal line. When you change the xy to yx, that's what you end up getting. And this is basically just us talking about each one of the ways of reflecting. So all the ones that you are going to see on tests and quizzes will either be reflect over the y-axis, reflect over the x-axis, or reflect over that y equals x, which I just showed you just a second ago. So if you're reflecting over the y, so this is at 1, 1, 2, 3, 4, 5, 6. If this is 1, 6, then you know it's going to reflect to -1, 6, because we're reflecting over the y-axis, the x changes to the opposite. So that's xy turns into opposite xy. Now, the reason why I keep saying opposite instead of -x, and I know that's kind of the same thing, I'm making that distinction because if it's a negative number to begin with, like e is -2, 2, sorry, then that will end up at +2, -2, meaning that the first number changes to the opposite. So negative became a positive. It's not always going to turn the x into a negative if that's what I'm trying to say. So if it was in the negative already, then it's going to turn into a positive x. So reflection over the x-axis just means the y is going to change to the opposite. So xy turns into, reflecting over the x, so we know that x is going to stay the same, and it's the height that's going to change to the opposite. So point A, which is at 1, 6, like I said in the last one, is now going to be at 1, -6, because the height has changed to the opposite. All right, so this last one, by the way, this is reflection of the y equals x, and as I showed earlier, that's xy turns into yx. Now, all of these rules are listed right here on the table. Doing a couple of these, 4, 5 would turn into 4, -5, because the y is what changed to the opposite. Opposite xy, so 4, 5 become -4, 5. And then yx means 4, 5 becomes 5, 4, like that. Picking another one down here, -1, 8. So negative 1 stays negative 1 because x stays x, but the y changes to negative 8. Now, using this point again, opposite xy means negative 1 turns into positive 1 and y stays the same. And in the last one, the y and x just simply switch, making it 8, negative 1. Now, going down here and jumping down here, I'm given the reflection of the y-axis. I want to find out, well, where was the point originally? Well, I can use this rule again. Opposite xy to this makes it 7, 5. And if you think about it, if you go backwards again, use that rule for this original point, you end up getting that point again. Now that I have the original point, now I can figure out all the rest. This stays 7, negative 5. And this one over here is a reflection, so it's 5, 7. They're all reflections. I mean, it's a reflection over y equals x. So it switches the x and the y. And that's just the example of those. All right, and that pretty much brings me to the end pretty quickly. Thanks again for watching. Have a wonderful day.